All right, in this video, we are looking at giving you some homework help for the quadratic characteristics section. Okay, the first question says, use this graph to determine vertex axis symmetry, min or max. Okay, so there's the vertex. It looks like they've given us a point already for it, -1 and 2. That's nice of them. Is that right? -1 and 2. Yeah, that's right. Axis symmetry, of course, is x is equal to -1. You have to type that x is equal to. And then what's the minimum or maximum of the value? Since the graph opens up like this, there's a minimum value it can get to. And the minimum value is going to be whatever the y value is, +2. Okay, I think that's all they want on that one. Next question. For this function, find the vertex, axis symmetry, the usual. Oh, and they want us to graph it. To graph it, you need to use their tool, and I'll create another video that shows you how to graph quadratic functions or any function in MyLabs. But let's just find the information first. So finding the vertex, axis symmetry, min, max, and graph. Okay, so the vertex. Now this is in the standard form, so I'm going to use the -b/2a, which we'll use quite a bit, to figure out the x-coordinate of the vertex, then I'll plug it in. Okay, so -b/2 times a. So b is 2, and a is the number out front. It has to include that fraction. I'm calling it 1/2. Okay, so it'd be -2/1/2 of 2 is 1. So the x-coordinate of the vertex is -2. Now to find the y-coordinate, we'll plug in that -2 into the function. So, whoops, a little messy. So I have -2 squared over 2 plus 2x plus 1. -2 squared is a +4. So 4 divided by 2 plus, oh, I forgot to plug a 2 in there. No, a -2 plus 1. 4 divided by 2 is 2. 2 times a -2 is a -4. So 2 minus 4 is -2 plus 1 is -1. So the y-coordinate of the vertex is -1. Axis of symmetry, x equals -2. A minimum or maximum. Since this is positive, the graph's going to go up, so there'll be a minimum value. So it's going to be a minimum. And the minimum value is -1. So they just want you to type in a number. They don't want to say y equals -1. They just want you to type in a number. So it'll just be -1. And then use the graphing tool to graph the function. And like I said, I'll give you a video on that, but let's graph it, what we know so far. -2, -1, that's the vertex right there. I know it goes up, and I actually know that the y-intercept is this number right there, +1. So it goes through there. So it also must go through there. So the graph is going to look something like that. So when you graph it in MyLabs, you have to indicate where the vertex is, and you have to indicate one other point. For this particular one, I would use that point right there, 0 and 1, and that will give you the answer. If you get one that it looks like it and it has the right vertex, but it has a different shape to it, they'll mark it incorrect. So you have to make sure you get another point. And like I say, I'll do another video that shows how to do that. Graph this function, okay? The vertex is going to be at this number, so +3, and there's no number out here, so I assume it to be a 0. So the vertex has to be 3, 0. Because there's a minus, it's upside down. So I look over and see if at 3, 0, there's a thing that goes down. Not that one, not that one, that one. It's this one right there. Upside down, vertex 3, 0. Question. Graph this one. Vertex is, where'd my pen go? My vertex is -7 and a +1, and it's positive, so it goes up. So -7 and a +1 right there. There's your vertex, and it goes up. Which of those look like that? Not that one. These are going down. Has to be that one. Ooh, another one. I'm liking these. -8 and a -2, that's my vertex, and it opens up downward. So not this one. And the vertex is at -8, -2. Well, that's in the wrong spot. That's in the wrong spot. This one, -8, -2, is pretty close. You can zoom in on my labs to make sure it's correct, but I'm going with that one. Determine whether the statement is true or false. The function has a minimum value. Oh, I don't know. Well, this is minus, so the graph has to be upside down like that. So there's going to be a maximum value. Ooh, I'm giving you a false on that one. Given the following function, find out everything there is to know about it. Okay, so here's our function. Let's go over here and figure out what the vertex is. I'll just for fun figure out what the vertex using the complete the square. So I'm going to pull out a 2, leaving me with x squared plus 2x minus 48. And then I divide 2 by 2 and square it. That'll give me 2 divided by 2 is 1, squared is be a positive 1. So this will be a plus 1. But then out here, I don't put a minus 1 because actually if there's a 2 in front there, the change that I made there is 2 times 1 is a positive 2. So I'm going to subtract 2 out here. So I'll have 2. Then this, when I factor it, will be x plus 1 times x plus 1, or x plus 1 squared. And minus 48 minus 2 would be minus 50. Okay, so from that, my vertex is minus 1 and minus 50. So let's see. Oh, there it is right there. Minus 1, minus 50. Determine whether the problem has a maximum min. Since this is positive, it opens up, so there'll be a minimum value. So the open up has a minimum value. Yep. What is the range? So the range would be from here up, and that lowest point is minus 50. So the range would be in interval notation. The smallest number you can get is minus 50, and the highest number will be positive infinity. Now, you can it can get to minus 50, so I should put a square bracket on that one. On what interval is the function increasing? Okay, so if my vertex is minus 1, minus 50, way down there, and it's going up like this, okay, so from here over, it's going up. So that point, the x value is negative 1. So from negative 1 to positive infinity, that thing's going up. And on what interval is it decreasing? It's decreasing in this interval. So coming this way, it would be from negative infinity all the way up to negative 1. That graph is coming down. Ooh, I like that one. Baseball question. Here's the function, and they say, what's the maximum height? Oh, they should ask for the time too. Oh, well. Anyway, if they're looking for maximum, I'm thinking vertex. So I'm using my formula to get the x value of the vertex minus b over 2a. So minus b is 96. 96 over 2 times a. A is a negative 16. So that's negative 96 over negative 32. So those would be positive. I think that goes in there 3 times. Oh, I like it when they come out even. So at 3 seconds is when that baseball will reach its top height. Oh, but they want to know what the height is. So then I just figure out what the value of f of 3 is. So it'll be negative 16 times 3 squared plus 96 times 3. 3 squared is 9. Plus, what will that be? 18, 1, 288. 16 times 9 is 144, I think. Negative 144. And negative 144 plus 288 would be 144. So the maximum height will be 144 feet. And that happens at 3 seconds. They didn't ask for that, but I'll throw that in. Extra point. Aki's bicycle design determined that X 100 bikes are built. The average cost is given by that. minimize. So minimize, I'm going to find a vertex. So to get the x value of the vertex, minus b over 2a, b over 2 times a. b is negative 1.1, and a is 0.2. So it'll be positive 1.1 divided by 0.4. Okay, I need my decimals here. I just grabbed a calculator. 2.75, that comes out to. Okay, so, oh, and that's the end. How many bicycles should the shop build to minimize that? So that's this number here. So the vertex, this first value of the vertex, 2.75, that's going to be the number of bikes. And then this thing here will be the cost. Average cost. Yeah, so this would be cost. But they didn't ask for that. All they want are the number of bicycles. But then they said it's X hundred bicycles. So really I should take this 2.75 and multiply it by 100. That would tell me how many bikes. So it'd be 275. That's what I'm putting there. Sell 275 bikes, you minimize your cost. Last question. Graph the following function. Ooh, that's got an absolute value in it. And all those graphs at the bottom look fairly funky. W and M graphs. I think I'm ruling this one out right away because this is positive. So it's either one of those three. But these are sort of double parabola things with the square root sign. Maybe to figure out which one it is, I can start plugging in some values for x and figure out what it would be. A real good one would be 0, because that'll give you your y-intercept, and this y-intercept is 0. This one is, I don't know, 10, something up there. And this one, y-intercept again, is at 0. Well, let's try it. Anyway, so absolute value is 0, minus 5 squared, minus 13. So 0 minus 5 is negative 5, minus 13. Negative 5 squared is 25, minus 13 is 12. So the y-intercept should be about 12. That one looks sort of fairly close to 12. This one looks to be below 0. I don't think it can be that one. And this one, I don't think it could be that one either. That it has to be this one. Let's try another number though. Let's try, say, 5. So let's plug in 5, just to confirm. So absolute value of 5 minus 5 squared minus 13. So absolute value of 5 is 5. 5 take away 5 is 0. 0 squared minus 13 is going to be negative 13. So for an x value of 5, I better come up with negative 13 as the y value. So this is 14. This would be 7. Oh, let's do ours. So this would be 7. So 5 is in here somewhere. So if I come down there, yeah, it's plugging that. I could see minus 13 out of that. Whereas this one over at 5, this one is above, so it can't be that one. And this one, 5, is about here. Oh, see, it could have been that one. But I ruled that out for the y-intercept. And this one here at 5, that's way too low. Couldn't be that one. And you could keep doing that if you wanted to, say, figure out what f of minus 5 is. Come up with some numbers, and then just check the graphs and see which one it is. I'm pretty confident mine is that one. The other thing you could do is just plot that in decimals and see which one it looks like. All right, hopefully that helps you with this homework.